everybody, it's Dr. Gray. I wanted to go ahead and get back to working through some of the final exam problems for your 1141 exam. This is questions number 5 and 6. So question number 5 reads, when an aqueous solution of AgNO3 or silver nitrate and Ki potassium iodide are mixed, AgI or silver iodide precipitates. The balanced net ionic equation is. Okay, so whenever you talk about a net ionic equation, what you need to understand is that this is simply going to be the reaction of aqueous substances. So two aqueous substances that precipitate and form a solid. So whenever you're looking at a net ionic equation, then what you're looking at is basically the net. What is formed? What is included, or what is required to form or to produce a solid? Okay, so that's going to be your guide whenever you're looking at this sort of problem. So with that said, oopsies, sorry about that. Erasey. That's all that we really want to look for. So we are looking at our, we're looking for AgI as the lone product and as a solid. So if we look at answer option number 1, AgI is a solid, but this is also showing KNO3. Well, that's aqueous, and that's not going to be a product in a balanced net ionic equation. AgNO3 for answer option B, that's the lone product, and that's actually not a solid that's precipitated. This answer option B makes no mention of AgI. So that eliminates A and B. Okay, now answer option 3, that shows AgI as an aqueous substance, and that's not the case. It would be a solid that is going to precipitate. So answer option C is out. Now we're left with D and E. Okay, so again, what our goal is to add an aqueous substance, another aqueous substance, and form a solid. When we look at this, D and E, we've got aqueous, forming a solid. Now answer option E, aqueous plus an aqueous, forming another aqueous. So that's all going to be taken off the table. So just by virtue of aqueous plus an aqueous substance yielding a solid, using that sort of format, and recognizing that as a net ionic reaction, we are simply going to be left with D as our correct answer. So whenever you're looking for that sort, or whenever you see that sort of problem, keep that in mind. All right, so question number 6 is when the following equation is balanced, the coefficient of H2S is blank. So essentially this is looking for, is there a number out in front of any of these substances? So FeCl3, which is iron 3 chloride plus H2S, yields Fe2S3 iron sulfide plus HCl. Now what this is asking is specifically right here. What do we have? Question mark right there. Okay, now one way that you can look to balance an equation is do what is known as the guess and check method. So what we can do is pick out, well, we've got 2 hydrogens on this side. On the reactant side, let's throw 2 in front of the HCl on the product side. And basically, you kind of bounce back and forth, because whenever we add that 2 in front of HCl, that means we've got to balance the number of chlorines on the reactant side. An alternative method is, in the way that I like to balance any sort of reaction, is to do it the algebraic way. Okay, and the algebraic way consists of putting a letter in front of every single substance in a chemical reaction. And then what you're going to do is look at each of the different atoms, or each of the different species of substances. So on the reactant side, we have Fe, we have Cl, then in our next molecule, we've got H and we've got S. Now what we're going to do is set up an equation that relates the Fe on the reactant side to the Fe on the product side. And the way that you're going to do this is you're going to look at what is the subscript for that Fe, and then you're going to relate that to your coefficient. So the subscript for this Fe, there isn't one, so that implies that it's 1. And so what that means is you would put 1 times A, or simply A. Okay, you're going to set that equal to the number of iron atoms on the product side. The number of iron atoms on the product side is found as 2 for a subscript C. So 2C. So this shows the number of places, or the number of instances, where there's iron on the reactant side, iron on the product side. Now, next up is going to be, you're following the same thing. 3A, is there chlorine anywhere else on the reactant side? No. You're going to set 3A equal to D, because chlorine is only in HCl on the product side. Hydrogen is found as 2B, because there are 2 hydrogens in molecule B, okay? Hydrogen is found nowhere else on the reactant side, so we're going to jump over to our product side, which we will set that equal to D. And then finally, we're left with sulfur. Sulfur is only found in molecule B on the reactant side, and it is found in molecule C on the product side, and there are 3 C's. Okay, so what we're going to do is I'm going to switch to a different color, and I'm going to balance these chemical equations. What I want to do is I want to find a definition or a number for A, then for B, C, and D. And if I have those, well, then I balance my reaction. What I want to do is I want to set A equal to 1. Whenever I set A equal to 1, I'm going to plug that back into this equation over here. So 1 is equal to 2C. Therefore, 1 over 2, if I do the algebra, divide each side by 2, I'm left with that is equal to C. So C is equal to 1/2. Okay, now I'm going to do the same thing for this next equation. So 3 times 1, which is my value for A, is equal to D. Now, that means that 3 equals D. So D is equal to 3. Now my last equation here, or not my last one, but my next one is going to be 2B equals D. We don't have a value for B, but we definitely have one for D. So I'm going to say 2B is equal to 3, my definition for D. Divide each side by 2, divide by 2, B is equal to 3/2, or 3 over 2. So at this point in time, I have one more equation that I can solve for, but do I even need to? No, I don't. I have values for A, B, C, D, or A, B, C, and D. Now what I need to do is I need to make sure that these are whole numbers. And luckily, 2 of these are divided by 2. So all that I need to do to make them whole numbers is divide these by 2. And if I do that to one of them, I need to do that to all of them. So 1 times 2 is 2. 3/2 times 2 is 3. 1/2 times 2 is 1. 3 times 2 is 6. Okay, so now that gives me my definition. Now my balanced equation, if I write this out, is going to be, I'm going to pick a good color here, orange. So I'm going to say 2FeCl3 plus 3H2S yields 1Fe2S3 plus 6HCl. Okay, so that's my balanced equation. Now before I proceed, always what you want to do is make sure that you've got it right. So how do we do that? We simply do it by looking at our coefficients and the numbers of Fe, Cl, H, and S. Okay, so on my reactant side, Fe, I've got, well, 2 as my coefficient, so there are 2 iron. Cl, I've got 6 Cl because my subscript is 3 and I've got a coefficient of 2, so multiply 3 times 2. H and S. I've got a 3 coefficient out in front of my H, so that would mean with a subscript of 2, I've got 6H and 3S. Now on my product side, I've got 2Fe and 3S. Well, I've got 3S. I'm just going to align all these down here at the bottom of the page. Then my other product, I've got 6H and 6Cl. So it looks like I'm balanced. So now I have to retreat back to my question, which was, when the following equation is balanced, the coefficient in front of H2S is what? And B, 3 is my answer, so I'm going to write B as my answer. Anyway, I hope this is helpful. I'm going to go ahead and stop this video and proceed with some more questions in just a second.